Hello, Rob Macbeth here, and we're ready to begin another lesson in physics following the Learning Outcomes Core 2 and 3 on the 1.1 Physics 025 syllabus. Let's begin, shall we? How to measure time. So it's obvious, I hope. You can measure time using a wristwatch, a stop clock, a wall clock, and an hourglass timer. Examples of such devices are pictured. So you can see we've got there a analog here and a digital display. I'll just point out, here's your analog here. Just write down here analog. Once I get the pen going, I'll put it in green. So here's analog. And here's a digital display. This is your digital stopwatch. Here's your wristwatch, which is digital. And then we've got a scale for this egg timer. On to the second slide, how to measure time with greater accuracy. So we'll have to measure the speed, example, measuring the time for a sound of a whistle or a starter's pistol to travel over a distance of 300 meters. These are the equipment that you'll need. So you need a stopwatch here, a tape measure, make sure you pre-measured this distance of 300 meters or 200, and then a device such as a starting pistol or a whistle. So you would measure the time taken maybe 5 to 10 times over the distance of 300 meters, so we can find the average speed more accurately. So you'd find the average time, say 10 times, whatever that may be, say 10.4 seconds, and then divide it by 10, and then you find the average speed that the sound travels for that distance of 300 meters. Another one you can do is average speed of measurements. It might be included time taken for a ball to fall from a high window. So then you can measure that accurately. Do that several times again to measure the time to find the average. Here we just got a few of the instruments here when we have a look at the time for a pendulum, which we'll see in the next slide. How to measure time with greater accuracy. Here we'll be looking at a pendulum here. So we can see here a pendulum. Increase the accuracy of time for a single swing of pendulum by increasing the number of swings completed by the pendulum. Then we can find the time taken for one swing. So what does that mean here? If I do it in a different color, I'm going to say red. So this will be a swing starting from here, so it goes here, and then we come back, and that'll be the finish. So that's one full swing of a pendulum. So how to measure time with greater accuracy? We can then use a bit more modern equipment. We can then use automatic timing, collecting data using photo gates like this one here. And then we can have the pendulum moving through a photo gate here when it moves across and then comes back. And then it can accurately time passing through the photo gate, which gives us a time when it starts and finishes. In this case, it can be a light sensor photogate to measure the time it takes to complete one full swing. We know this in the pendulum theory as a period. So the period is where it goes from one whole distance from the start and then back again, and that's called one period. Now with all my little short videos, we've got to test out to see if you actually know the work. This is fairly simple, but make sure you don't lose these easy marks. We go through the question. It's a quick 3, and here's the question. Determine the time or times on these different types of measuring devices. So down below we have this wall clock, and I would like you to answer the question on this wall clock. The time is, pause the video, and then give yourself some time to answer the question. Next question to part 1. Part 2 is we're now looking at a different measuring device for time. What does the number represent on this stopwatch? So we've got a stopwatch there, and it's got its little start and split buttons here and here. What does the 11 represent? This is this number here. The 11 represents, put in your answer. Remember to pause at the end of this so that you can have time to write your answer. So this second question relates to a pendulum swinging, a typical question that you will probably get in your physics exam, either in the experimental part, short answer or longer answer. So the question reads, a physics student measures the time taken for 25 swings of the pendulum. She finds the time taken was 175 seconds. And the question I pose, what time does the pendulum take for one swing? Show you're working. It's always important to show you're working. So again, pause, give yourself time to answer the question before you go on to the answers shortly. In the final part, question 3, using the previous pendulum experiment, how could you have found the time for one swing of the pendulum more accurately? So give yourself time to have a think about that. Pause again to answer the question. Good luck. As I said, here are the answers to the question, so please check these and give yourself a quick mark. The time you should have got is 11:29 in either the morning or the evening, or as a number, you can write 11:29 a.m. or p.m. Remember, a.m. stands for after midnight and p.m. stands for past midnight. Let's have a look at the second part of question 1. Answer. So B here is, what does the number 11 represent on the stopwatch? Pictured below, you can see 11 represents 11 hundredths of a second, or as a number, 11 over 100th second. Okay, for the second question, here is the answer. What time does the pendulum take for one swing? 25 swings takes 175 seconds. That's in your question here, 25 here. How long for one? You divide that 175 seconds by 25 to find for one swing, and one swing equals 7 seconds. Well done if you got that right. Okay, final answer for question 3 in the quick 3. For the above pendulum experiment, how could she have found the time for one swing more accurately? 2 alternatives to the answer. Using a greater number of swings for the pendulum increases the accuracy of the time taken for one swing. So if you did it for 10 swings, maybe you might want to do it for 25 or 30. Or you can use an automatic timing sensor to measure the time it takes to complete a full swing. And we know in the pendulum, it's called a period. I hope you did well in that. Give yourself a high five, big high five, air five. Well done. It's all part of the learning process.